Gibson Hanks, welcome.
Hi.
Welcome. So I don't want you to feel uncomfortable. We can edit whatever. So I thought today would be fun. I talked to your dad a little bit ago. He told me that you are just way into computers and really good with them. And I thought, wow, I bet you probably don't have too many opportunities to talk to folks that have been in doing this for many years. So I thought you'd have fun with this too. And I understand you might have built some stuff. I'd love to see that when we get there. But let's start with, tell me a little bit of who you are, where you're from, what kind of things you like, and then we can go from there.
I'm just a person. I don't know. I'm California. Just like computers. Most of what I do is on the computer. Not really sure what specifics I should be getting into.
So would you say you're 17?
Yeah.
Yeah. But you've lived in California your whole life, right? In fact, you live in our neighborhood now. And I know you lived in a different neighborhood, but then you came back. Or have you always lived in our neighborhood?
Yeah, they were in Bonsall for a bit.
So I understand that you first got a computer at what age? Do you remember?
I don't really remember much.
A few years ago? 4 or 5?
A good while ago.
And you've been pretty much working on the computer in a huge number of ways for, let's say, just several years, right?
Yeah.
And did you take classes or did you teach yourself?
Mostly self-taught. I did used to look at an online course back when I was trying to, pretty foolish sounding now, but I was trying to start out with C+ instead of learning that one later. Gave up on that kind of fast, but...
Yeah, it's interesting. Pull closer, a little bit closer to you. C+, you jumped into that as your first. Now, first of all, that is hugely impressive that you would even have thought to jump into C+. So what made you think to do that? That's object-oriented coding is pretty tough to start with.
People said it was hard and that it would have like good things to learn that could be applied to other languages. So I just thought, why not? If I can do that, everything else should be easier.
Yeah. But you didn't frustrate too much and to the point that you gave up on computers. You just thought you'd try something different. What was the next thing you did?
The next thing I did was mostly play games for a while. I gave up on coding. Most of what I did was Visual Basic scripts. But then I got back into it and decided to try with something more beginner friendly. So learned Python, mostly self-taught there. And I've also been getting into just everything web related recently. Mostly JavaScript, mostly using WebGL Canvas stuff, but I do know the basics of CSS and HTML and how to make a website, and I can, in JavaScript or Python, set up a web server to host it from, but I don't like to.
So when you're on your computer, and you said you work primarily on a laptop, you just have a tower, but in the computer system here, I imagine you launch Python web servers to actually then do the web work locally on that machine?
Yeah.
Okay. Have you ever done any cloud work, cloud computing work?
No, I have not done anything with cloud computing.
Yeah. It's not to be afraid of. You're probably aware of what you do there, but you can pretty much launch an instance of, say, a Linux server, connect into it. These things, of course, they always require extra cash, money. When you're 17, you're probably not like working and generating a ton of income yet. So
I'm trying to get there.
Yeah. There are a ton of, so you are in a really exciting time right now because when I was 17, I had a Radio Shack TRS-80 that internet wasn't around, right? And I had to code on it and save to a little cassette. And it was like you're isolated just into that environment. But so you have the access to all these world tools. But what's even more exciting is that you have access to environments that you could build, basically businesses down the road. And you're the only person in the business. Solo entrepreneur stuff. So when you say you don't have, and you're working on it, but you don't have currently income flow, my guess is in a year or two or sooner, you might.
I have been looking into things that I can release and probably going to start with free open source stuff.
Excellent.
Just to get people in and all, but
Yeah.
I've actually also been looking at the stock market.
Have you?
Yeah.
So what do you do? What are you doing there? What are you thinking about?
I'm thinking there's probably some way I can connect historical stock market and news data together to feed it into an AI model.
Yeah.
But there's probably something I can do there to effectively predict future stock prices from just the news.
Yeah. Yeah, I think you can. You know, it brings back a memory when I was in undergrad and in college. I was building using just simple regression models, real basic stuff nowadays, but just taking nothing more than the historic stock price for a particular, just one ticker, and fitting curves to it. And my friend, every day, he had a newspaper. He'd give me what the stock price was because I didn't have access. I'm laughing because now we have historic data online. You get it immediately. But it was literally from a paper, and he'd tell me what it was. And I'd key it in. And even then, we're talking about almost 40 years ago, that the big challenge was getting the content to build, or at least enough to build a model. And then I was predicting, and I'd say, don't tell me what the price is. I think it's this. And we were pretty close every year. And it turned out I pick a ticker. I think it was IMPCHM, Imperial Chem. And it was very cyclical. And so it was a simple sine type curve to fit to it. But that was just based on its historical price. But what you're talking about is using a huge amount of like news item information that's perhaps unrelated that most people think, but you somehow massage it into a model to make a prediction. So what's guiding your thinking there? Or you just think that's a general thing that would be cool to do?
Mix of like specific things and just that would be generally cool and helpful. But I personally do think that everything can be represented with a function. No matter how complex, you can simplify it down to just math and numbers. So I think that if I can get enough input data and figure out what the right weights are, or more accurately have an AI do that for me, I can get accurate output data predicting the future, essentially.
Little Newton. Impressive. So I say Little Newton?
Isaac?
Yeah. Yeah. So Newton had the thinking that you could pretty much do what you just said, formula out everything and anticipate or predict the future if you had basically everything defined in terms of formulas. But then this other dude came along by the name of Schrodinger. You ring a bell? Yeah. So he thought, you know what? It's not so deterministic. It's more, there's probabilities and there's chaos and all this stuff. And those guys, I don't think they were around the same time. I think in historical, they might not have overlapped. But in terms of the actual kind of mindset, when you look at things like the market, there's so much information and there's so much randomness, stochastic type feature. I would lean a little bit more towards the Schrodinger thinking on these things than like the deterministic formula fitting thing. But that's just my thoughts. Do you think that you could, in principle, fit enough curves to model out all this complexity?
Yeah. Like, at the minimum, what I want to try to do is have something that takes high-level data, like summarized stock things and connections to historical events. Like, we can look at the news for, say, Google, see what's happening with the company right now, what's trending, what people are saying about it. Just summarize that and predict not exactly the stock price, but maybe just if it'll go up or down.
Yes.
And then keep doing that for a while, see if it gets more accurate, less accurate, does it?
Yeah.
And if it does, I guess we have a stock predictor.
Yeah. So I don't know if you followed how the original large language models were exploited. I don't know if you saw, I don't know, you probably didn't read, but you've heard of the Attention's All You Need paper in 17.
I have read it, actually.
That's impressive. What?
I should have I have a folder back on my desk. It's just AI papers.
I
I have them all printed out so I can read through them.
Oh man, that's impressive. Now, honestly, I didn't thoroughly read Attention's All You Need. And I did my PhD in neural network computing. I glanced through it. I'm like, yeah, it's obvious to me. I don't need to read every formula and every paragraph. But at the end of the day, it's impressive you could even understand that. And that's really cool. But so that was basically put out to the world. And OpenAI, I mentioned this in other casts, they exploited it in the public more than Google did. And they used Amazon reviews to arrive at sentiment analysis. Basically, here's a chunk of text. Is it saying something positive or negative kind of thing? And what you just said with respect to stock market, if you took all the news and somehow embedded that with enough token length into a model, you could, in principle, predict the sentiment of how people are feeling or thinking, and do they want to buy or sell, which ultimately pushes a stock or a set of stocks up or down. So it's very similar in principle, but here's the deal. With respect to stocks, have you ever heard this phrase, buy on rumor, sell on news?
No, I have. I am not super into stocks. I just think this would be something cool to do.
Yeah. No, I'm just saying, no, the thing is that's an example of there's a bunch of insiders that don't release information to the world, and it's not out there for you to actually get this sentiment type analysis. And they're the ones often pushing the stock market up or down. Yeah. And so there's this confounding factors and it comes down to what is provided as input into your model, and you wouldn't have had that in. So it's something to think about in that particular case, but I just throw that out. It's really cool you're thinking that. And then what other applications you're thinking about as you scan through your AI folder? Stock market prediction, what else?
I am one of the, I guess, fringe weird groups in AI thinking that personally don't believe in larger models and think that we should get higher quality data and better processing of that data. So I just have random little ideas of things that I want to implement and see if they do better or worse than a more traditional AI system.
So some of these mini project ideas, what are ones you're thinking of? Just throw a few out. I'm just curious.
The one that I've been working on right now, it's not speech synthesis, but instead of using AI to completely generate the audio, I want to use AI to optimize parameters for like a more standard method of speech synthesis.
Okay.
But you've probably heard of source filter models, right?
Maybe. It doesn't ring a bell. What is it?
It's a method of speech synthesis where you take a source sound and run it through a set of filters to just change the frequencies and all that, so it sounds like a human talking.
Okay.
They are known to have many hard-to-optimize parameters to get it to sound like a specific voice, so I'm thinking maybe we could do something similar to what we're doing with AI to optimize those parameters to someone's voice.
And then so what do you see the application there? You're going to train. Tell me a little bit more. I'm not sure I follow exactly how you expect to use this.
Well, speech synthesis now, the popular stuff, like do you know what Vocaloid is?
No.
It's basically just a fancy concatenative synthesizer. So it takes little clips of people talking and it modifies them and concatenates them together.
Okay.
But that takes a lot of storage space for all of the audio clips. So I'm thinking maybe we can get the quality of that without all of the storage requirement.
And I see the utility there, of course. You can bring the footprint down, but where do you see that would be used? It's a mom and pop general population. How would they use it?
This isn't really targeting as much the general population as it is specifically the group of people who are into using these text-to-speech things. Like, you can go online on YouTube and find people making music with Vocaloids and Utaus, which is an open source version of basically Vocaloid.
Okay.
There's also this new one called SynthV, which is again, concatenative synthesis, but it uses its own AI to smooth out the in-betweens for the two sounds.
Okay.
And there's a lot of people that make music with that as the vocals, so that would be my audience for this.
I see. Interesting. Well, yeah, I imagine I'm not trying to discourage you in any way. I was just exploring. A question I always ask when people say they're working on something is how does it apply? What's the utility? What's not just the novelty? Is there a need for it? Why you're working on it kind of thing. I'm sure you're familiar with 11 Labs, right?
Yes, the voice cloning service.
Right. They do a lot of things. And so they're like way ahead of everyone else. Basically, text to speech in almost every language you can imagine. Really powerful. I use it all the time. In fact, the AI apps I'm going to talk you through after you show me yours. I built an AI Dad. I built an AI Steve. It's a chat interface that responds back. It uses RAG, a retrieval augmented generative AI. So it uses the content that I have for me and my dad, and it will build up the complex prompt to use the LLM to respond back. So I can chat with basically a surrogate of me or a surrogate of my dad. But I have the text come through and I send it to 11 Labs and it generates effectively the audio files. But I've cloned my own voice. So I basically can talk back as if it were me. It's fairly quick. And that comes back in English, but I could have it come back in Japanese and Chinese and whatever it is. And so because they're so far advanced as far as commercial utility, they're a company I encourage you to keep your eye on, because as you develop technologies like this, you might one day just contact them and say, hey, I've got this really cool footprint reduction strategy. And it's a technology that they might say, holy crap, that's really cool. And come do a summer internship with us. Or, hey, we'll just hire you. So just keep an eye on guys like that. But
I have seen the things they do. It is pretty cool, but there are also problems. Say if you put in a large just string of random text, it'll make something up about it because it doesn't actually know what it would sound like.
And so you're proposing a strategy where it's going to be more accurate, if you will, from text to speech as well?
It would reduce the amount of random noise that comes through because we have these predefined things. Like the sounds that it makes are already decided, so it's not going to say, if you have someone going, it's not going to throw a random noise in the middle just because it thinks it might fit there.
Just as a side note, yesterday I was outside and I heard this bird and it was going, mama. I'm like, wow, that literally sounds like mama. And I was thinking, is that a baby bird that's born advanced? Let's call it from its mama. Or was it just, it came up with a sequence that it could enunciate through its capability, vibration, whatever it is. And it recognized that there was an effect when it produced that, the cause effect kind of thing. And it learned and reinforced. And so if you think about how we use language, it's often evolved in this cause effect manner, right? And there's an input and output, but I produce something and I get a response. And so when you're thinking through this, are you thinking about training your model in a supervised manner in which you have a training set that you somehow annotated, where you have the right answers already and you're training the model to that? Or are you going to try to do this with an unsupervised model strategy?
I will probably be supervising this one, but I might try to do some sort of unsupervised learning if I want to, eventually. But as this is right now just a personal thing, I want to get a first fully working thing out there. It is probably going to be something that I can supervise, so I can make sure it's giving me what I want.
And so is that one of the things you built that you were going to show me? Or is that something different?
That is the one that I have most complete to show, but really not that much. I don't even have the AI in there yet.
And so the reason I ask about supervised versus unsupervised is I used to dabble a bit with the unsupervised world. Early Kahuna neural network stuff I was working with, that's unsupervised, but I've had most success with supervised models. And at the end of the day, most AI applications are that I have supervised level data are the best, right? Maybe that's overstatement, but the LLMs today, that's effectively supervised learning because the next token prediction came from data that was already produced and you knew the answer and it was already pre-annotated because you had the full sentences and you just used that data. It's self-inherent supervised data. And so with sound, as you think through this stuff, if you gather a bunch of data like forest acoustic data or data you hear outside, or you have almost like stock market prediction, you have a series of input that come in and the next token of sound that is actually observed from what you collect for your training set, there's a whole bunch of supervised data you could learn from. So anyway, just throwing that out there if you hadn't thought that way. Mm-hmm. Do you follow what I mean?
I'm not really sure about the language, though. You say supervised learning, but you're describing labeled training data.
Right.
But you are also talking about large language model, ChatGPT, which
right.
use semi-supervised reinforcement learning.
But I would argue that the data that's used is inherently annotated already. And that's why I would characterize it as fully supervised. Right. From my perspective, because I'm very rigorous in my own thinking with this. If the input, the full input that comes in has the answer somewhere already labeled as you're calling it, and in fact, we do have that because if we have, as we stream through a sentence, the next token, we have the sentence already. Even the diffusion models, I would argue, that people are working on are still a form of supervised training. They're annotated because you have the ground truth and you randomize, but you still have that ground truth. See what I'm saying? So it's not like a pure unsupervised scenario where you've got just this glob of numerical representation and you're not sure at all with how to characterize or classify. There's no annotation there at all. So that's why maybe you're seeing it differently. You read the damn attention. It's all you need. It's paper. But I look at it again in terms of what comes in and what comes out.
The data is labeled by humans. It is not learning on its own yet. I don't know if we're even there yet.
No, I think you're exactly right. It's not just the data that was labeled by humans. It was created by humans. All the content that these LLMs are using all that LLMs are trained on, it's largely content by humans. When data that's created by some other AI or LLMs is used as input, it's already starting to get garbagey, as far as I'm concerned. That's why you really want to have good quality training set data that's actually purely human generated. Arguably, if you have video that's taking images of people interacting, cars moving, just even animals in nature, but there's a video, that's still arguably human generated. It's biological generated. That's what I'm saying. So that's what I'm saying in terms of like having inherently already labeled data for your learning set.
Yeah, it makes sense that if we want to train it to mimic something, we should get the data on that thing from the source, the thing.
Exactly. But a training usually involves you've got an input and an expected output. It usually involves that. And so the expected output means you have had some labeling or some annotation. And so that's what I'm just saying. Whatever problems you go after, make sure you have, from my perspective, think of it as supervised and that you have some annotated data that's good quality that you're using for your problem.
For what I'm doing here, the input to it would be like, I want this vowel sound, and the expected output is, say, a recording of me making that sound.
Yep.
And I want it to learn that when I ask for this vowel sound, it should give me the data to run through my own function to produce a sound acceptably close to the original recording.
Exactly. Because the error between what is the error that's over the sum of the data of expected versus what it produces is what you try to minimize when you optimize the weights in the overall model. And so that's just a traditional training strategy, right? But again, the key is you need to have what the answer is. You need the answer key, is what I'm saying. And I know a lot of people are more theoretical in their thinking. It's, oh, what if we don't have the answer? I'm like, yeah, no. I'd say focus on things that you have problems where you can train it on examples that you have answers so that you can use it for cases where you don't have the answer yet, but you'll have a good sense of how predictive it is. So at the end of the day, again, I use that phrase too often. Building models for extrapolation, that's where it's at, baby. Where you're predicting something that you hadn't been trained on before. Interpolation's not so challenging, but extrapolation's really cool. So you got the sound, you got stock market. What other projects are you thinking about?
I've noticed that most LLMs split text up into tokens, and I'm weird. I don't like tokens. So I do want to try to make an LLM that works with just the text, uses each individual character instead of a token.
Yeah. Interesting. Why?
I just think token representations are limited. Like, you have this fixed number of tokens. If you want it to make something that it doesn't have a token for, it can't, and it's limiting its understanding and ability to reproduce things. If I could get something that understands just a stream of characters and produces another one, I feel like that would be a bit closer to human-like and just more able to make human responses.
So let me throw something at you here. Humans have multiple sensory inputs, right? The visual, auditory, smell, and taste are coupled, often touch. All these different sensory perceptions are effectively converted to some sort of chemical and electrochemical transmission for the brain and all that. But all those inputs are different patterns. And we evolved, and so did a lot of biological animals below us, with very similar sensory perception that are almost arguably somewhat orthogonal, meaning they're useful altogether to fill out a perception in a way that just makes sense. And we don't have too many senses. I mean, you could argue you have the sixth sense, the five senses and sixth sense, but there's still a small number. The written word, animals don't use it. That's human. And to me, it's almost like a level of abstraction that we might want to even cut out of the equation. What if we could use effectively the things that we perceive, imagery, sound has a waves, which is actually a pressure vibration thing, and touch is very similar to that. But what if we use that as the kind of representation for input to these kind of models?
I think that would be the future of human-like AI, but that's just not what I'm focused on right now. I doubt I can get all of the data for a human's accurate life experience and run it through 3060 in my laptop.
Oh, yeah, but that's because you feel constrained by the hardware. But I'm just trying to get you to think a little bit about that as you look ahead. Humans are very storyteller based, all right? Let me ask you, when you think about or come to conclusions or have mindsets for certain things, what goes through your mind on how you can extrapolate from an experience?
I don't really know.
You have to answer right now, but think about that, because I'll give you a good example of what turns to something like a present day application that I've just been working on. I know humans often tell stories to one another to communicate learning experiences. And we are very visual with storytelling, but as general humans, some people don't see when someone's telling a story, like they don't imagine themselves. If you're sitting around a campfire and talking about a story, some people don't have the ability to put themselves in that story and see what is being said and hear and smell and taste. They don't do that. Other people are very vivid with that. So when they hear those stories, they get all those sensory perceptions in their brain and they learn from that. When you hear something or you learn from something, just reflect for a moment. What goes through your mind? Let me be more specific. You were learning a language, like a Python language. Let me ask, what was like the first concept that you've learned with computer programming? So looping, if then clauses, what was the first thing you remembered?
Printing to the screen.
Print the screen, hello world, right? Mm-hmm. You remember that right away, bam. What do you visualize?
It's the first step for everything.
I don't know, every time I see hello world in new languages, I just barf. I just jump right into, show me how I can do a loop, or what's a conditional, right? And if I say right to you, I need to do a loop within Python, what comes in your mind right now?
A for loop.
And then, so do you visualize like the structure, the syntax?
I know what I would probably put out if someone wanted to say just loop 5 times. For x in range 5.
Interesting. There you go. And so you knew the syntax right away. I'm just like, I forgot what's this. I remembered like the early basic for I equals 1 to 5. That was my first language. And so it's funny that you jump to that, but you visualize the characters in your brain when you do that. Oh, interesting. Okay. So the cool thing about these convolutional neural networks is how they represent imagery, and you can do in different rotations and stuff. When you visualize that for loop, do you see it horizontal?
I see it like I read it in my text editor.
Yeah, so it's embedded in your brain that way. Yeah. Anyway, I'm just thinking, as you think about new representations, tokenization, I'm not a fan of, but if you really look at it, representation is key in all these.
You have to have accurate data to get an accurate result, garbage in, garbage out, and all that.
And ultimately, things get converted to zeros and ones anyway. But in terms of what's a really elegant representation, so you think about languages, we represent things in terms of words. And then you're arguing to the point of, okay, how about the alphabet, the 26 letters, or it goes beyond that with periods and exclamations and numbers and stuff. But the reason for tokens is you can group those together that often come together. It's an efficiency thing.
Yeah.
But what if you see an object that you can't put words to? What do you do then?
I guess if you would relay information about that object to someone, you would probably describe it.
And how would you describe it? Like a new object that you haven't recognized before. How would you describe it? What would you use? What features?
I can't really make that. The only data I have is things I have seen.
But you might not know what they are in terms of a label. So if there's an object that you've seen before, okay, you might have seen an object before, but you're not sure what it is called in our today's society. How would you describe that kind of thing to someone?
Probably just try to summarize like the main features of it, the most recognizable part of it, and hope that they know.
And so would you say things like color or size, shape, texture, those features?
Mostly just shape. I feel like other people visual processing makes up a lot of our brain. I don't think someone is going to say recognize a knife because the handle is usually black and it's shiny.
But they would see it as a sharp region and maybe it's silvery.
A sharp thing you can grab, cut stuff.
Right. Oh, so it's the object and what it does is a part of the description.
I feel like most people, if they're thinking of something like a specific object, they would probably think of what it looks like, seeing the shape of it, and how it interacts with things.
Yeah.
It's something that purely text-based models can't really do, which is why they'll probably never be accurate to what a human would want as an output. Like,
Right.
just an LLM with only text, if it didn't know from its labeled data of humans talking about like a fork, it wouldn't know that you use a fork to stab into food or wrap spaghetti around it or whatever.
Yeah. Inherently limited. And so I'll just describe this briefly, and then I want to, if you want to show it to me or not, I want to jump into that application. I said I did this AI Steve, AI Dad that's chat-based initially. What I've been moving to is image handling, because I found content is critical for all these systems. And the first step I always go through is assembling the content I have and either having it annotated ideally or come up with a tool to help me annotate it is critical. And so the text-based stuff was easy, right? Because that's just emails and iMessages and Facebook posts or whatever text exists already. I could easily use that as part of my content for my training. Imagery, like pictures and videos, a little more challenging. Now, the first step I could go through, and I have, is I use things like Claude Vision to do extraction of the textual description of the image. But those are tools that can't say that image is, say, a Tim Hanks, right? It says some dude with blonde hair. And for my use, I need to know who it is. So I need to annotate that.
They don't have their own memory of this person. It's
Right.
just someone they've never seen. They do not have something stored in their brain that says, this has a label. It is different from everything else.
Exactly. So the ImageNet work that was done years ago that came up with a bunch of images. And I don't know, do you hear the story? I just heard this gal talk. She was on Tim Ferriss's, it was a podcast, wonderful description of ImageNet. And it was work she did years ago, I think at Princeton, where they came up with a bunch of images and they needed to annotate them. And they used Mechanical Turk, the Amazon system where you could get individuals to just do things for you online for small sums of money but you just distribute over the world, and you had a ton of people annotate images for them. So they had all these, I think they started with a wine bottle label and a series of them, and they had them up in the cloud, and then you'd have individuals say, oh, that's a wine bottle, that's red wine, this date, and humans did the annotation, but they just spread it out, outsourced it that way, and they built this really large, good quality database called ImageNet. And by having that, then they could have all these classifications of images to what they were, which are critical for a lot of these things. And ultimately, the vision recognition stuff uses elements of that same kind of thing. Back to my point about my own images, I have thousands of pictures. Oh, and by the way, I have my AI system will suck data from my iPhone, iMessage, anything that you get on your Apple, I can pull into my RAG system. But I have these videos that are assembled pictures. And those were a little bit more challenging, but I could still use the same concept. First of all, I should say that there are a ton of tools out there that do image similarity. Is there image A, is it close to image B? And there's also tools to find sub-imagery. Whereas are there parts of image A that are within parts of image B? Like the Venn diagram overlaps thing. And therefore there's technologies that already exist, open source, that can say, are these two similar? Which means that you can then annotate one image, find all the images that are similar to it, and have those inherit your annotation. So I could have tens of thousands of images that get clustered based on image similarity and annotate, say, the cluster center, and have all those in that cluster get annotated. So suddenly I can go from just a handful of my manual annotations to tens of thousands of annotations with me not having to do the work. So that's something I've been working on because I wanted to have all these annotations so I can search them both by image and by textual type representation. So does that sound interesting? Is it cool stuff?
Yeah, that's pretty interesting. I just feel like if we were to use that as further training data, it would be limited by the fact that you can't accurately represent every part of an image with just text.
You're absolutely right. You're absolutely right. And that's why sometimes you just have to use an image as your query. So this is where a little bit of my own background outside of this space has been really helpful. I did a lot of work in the area of cheminformatics. Chemical structures are pictures. They're actually graphs, very simple graphs. And one of the first companies I worked for developed a technology to find a subgraph within a graph. And they called it substructure searching. They built a whole business on this. And the reason for the importance of it is these companies would generate a bunch of data off these chemical structures. Sometimes there'd be tens, hundreds, millions of chemical structures. And scientists would find that if you could find a subgraph within any one of those, compounds that have similar feature behave in the same way. And so the same concept holds true with some of this image stuff we're talking about. So the things that I think of is, hey, if I can't put words to an image, but if I have an example image that's what I'm looking for, all I have to do is an image search. I don't put text in between. I just say what images are similar to that image. So it's actually very appropriate for what we were just talking about, because it's all about representation. What if you can't put words to that object, but you have a picture of that object? That's your token. So maybe you could come up with a whole slew of sub-tokens that describe the natural world of the space you're working in. And those aren't textual representations. They're some sort of image block representation.
I think that's what diffusion models do.
Yeah.
Like in the in-between layers, they have different representations of the thing they saw that they're trying to reproduce. They have one neuron in a layer could be for this shape or this shape.
Exactly.
And they just build that up into the final image.
What's curious to me, have you ever downloaded any of these open source models, these LLM models? And when you see them come down, you see all these feed forward neural network weights just get downloaded. What amazes me is that people aren't looking at more within these complex models to find out what those internal layers of shape representations that it arrives at in order to do this reasoning.
Yeah. We do that all the time with like image models, actually. They develop strategies to have it reproduce what its pure idea of this thing that you've asked for is. But with stuff like language models, they've just said, that's a bit complicated. We don't want to learn computer language, so it's a black box. We're not going to look inside.
Yeah. When I was first doing my feed forward neural network work, by the way, some of the early papers I published were involving multiple neural networks stacked, which people later called deep learning. Yes. But one of the reviewers said, explain why it works. And I was spending, because I'm doing my PhD, I don't know. I got to find references, and no one was doing it. But there was one early work that was called contribution analysis that was starting to dig into the math of the hidden layers within the neural networks. And that was really cool, because as I was looking at that, I was saying, holy crap, there are some really interesting patterns within the hidden nodes. And then that actually led me to the next level, where I had a neural network try to learn from the hidden nodes. And at that time, I was contending with an issue called memorization that principle, I think we have it today.
We do.
Yeah. I mean, when you're talking about some of these LLMs that have trillions of adjustable parameters or weights, and the amount of data it's trained on is starting to become smaller than the number of weights we're involved, it's like we're overdetermined. It's like a big database lookup system. And so that kind of pisses me off, but that's what I had to deal with years ago when I had smaller data set size. So I trained a neural network to learn when another neural network was actually falling into a state of memorization. Because I didn't understand how, but I had another neural network figured out for me. It was really cool. So I don't know if people are thinking about that today, but
I think we have similar opinions on this. Like, not enough people are looking into what it's actually doing in there.
Yeah.
They just want the input and the output.
Yeah. You have to be pragmatic. It's, sometimes the world's so complicated you can't explain why anyway, and we just have to take an empirical approach. And that's, hey, if we have a black box that can figure out, if you give it an input, it gives you the output that's useful. Who cares what's on the inside? Just use that black box.
But I want to know and to figure out why when some inputs don't give the right output,
Right.
we have to know.
Yeah. That's the little Newton in you again, the deterministic formula fitter that hopes to come up with everything. But I think biology evolved these complex neural networks because they're very powerful in not needing to know why, but they can just learn from cause and effect. And I think that's it might be a local minima, but I think it's an effective strategy.
Still, it's not what we do with LLMs today. They don't have any actual like shared memory between them or anything. They just look. Their input takes all of the chat history.
Yeah.
That's how they remember.
Yeah.
That's not very human-like.
So there was a real interesting project we did after Max. I was using neural networks to build the prediction of conformational space of small molecules, chemical structures, and use that sort of space to predict how those chemicals would perform in a biological setting. So I had this representation we called farm print, where we take chemical structure and we rotate it through space and have all its representation. And that's a movie of the molecule. And we'd have all this data of how that molecule works in biology systems. If you take a drug, what happens to you when you take the drug. But we'd have all that data and then build models to actually make a prediction if you have new molecule, what its movie would be, and predict how it would behave in an extrapolative sense. Then the farm print technology of rotating through space was computationally expensive. And we did parallelize it to a certain extent. And then we were using precursor GPUs at that time. We were using silicon graphics machines that were just like the ultimately evolved into GPUs that NVIDIA's run away with. But you can't parallelize too much. You have to kind of do it in pieces. Regardless, we work with the UC Santa Cruz group to embed that conformational exploration code in chips. And they were using this Kestrel chip. And what took, say, an hour to conformationally explore a peptide's space with our normal, even pre-GPU silicon graphics world, we did in 10 seconds when it was embedded in the chip, because the algorithm was embedded in the chip. What I don't understand is that today, with all the LLMs that are being built, we just keep retraining over and over again. We can embed those models in chips directly, and we just run with it.
Actually, that has been done. Amazon's newest AI data center, I forgot a specific Claude model embedded on their own chip.
Is that the TPU? They embedded in TPUs?
No, that's Google. Google made TPUs and they do AI tasks faster. But Amazon has their own thing now that they are using in their own data center. It's a chip with a Claude model just built into the chip.
So they took
faster.
They just froze Claude 3, 4, 5 or something, and they put it right into the chip.
And they just have a bunch of those in the data center
That's
instead.
awesome. That's exactly what I would say. That's awesome. See, it's a perfect example. I don't feel bad not knowing that, because it's a full-time job to keep up with this shit. And so your folder for AI has got to be growing like just stacks and stacks. So how are you keeping up with it? Is it your full-time job?
No. Mostly I just put YouTube videos on in the background of other people whose job it is to do that, summarizing it.
Yeah.
But I do get learning from it.
Yeah.
I do get the info.
No, that's cool. You can multitask there. So they've embedded a Claude model. That's hugely impressive. Did they make that available to others, or they just use it internally?
It's just in their data center that they have. I feel like the reason people haven't done that more, though, is because the models learn by being retrained, which changes their shape. So you can't really have that in a chip without just making a GPU.
You know what? I think 4.5 is wonderful. Claude 4.5, Sonnet 3.5 was fine. 4.5 is great. It actually is a hassle. And because you do so much Python coding, you're used to this where it's constantly changing libraries and you're just like going through like this hell of every time the new Python library comes into play, you might be breaking your system unless you conda environment or you keep it static or something, but it's a pain in the butt.
And I actually don't have to deal with any of that.
Why?
I use Linux, specifically NixOS.
Yeah.
So what you are describing is like apt, I forgot what it's called, dependency L. Instead of having all of it downloaded to one place, if I want to download something, say I have Steam and Discord, and they use 2 different versions of the same thing, each of them gets their own folder, and they can have their own version without conflicting. Everything is an environment.
Exactly. And that's why it's just like hell, though, as far as I'm concerned, because if you have, like, you need to upgrade, look at the basic, like NumPy or something, and you have to upgrade it for some reason, and you have other dependencies on their sub-dependencies, it's hellish. I'm used to building environments that are, when you make them production ready, you release them and they're rock solid and they're not going to get disrupted. You don't ever allow these OSs to say, there's a patch, let's upgrade and change the OS, because it will break a ton of things. So I've always had issues with Python because it's the most sensitive, because it's just constantly changing if you have a huge array of libraries, even if you have them locally isolated, I think you have cross dependencies that you run into problems with.
Usually I just make that stuff myself. If I find something that I want for this specific task, I'm just going to recreate it myself. It's more fun that way.
You have extra time. No, hey, big guy, for 17 years old, man, you are your head on your shoulders because you're working in some very complicated areas. It just goes to show you that, look, I did an undergrad in engineering, a PhD, did all these formal coursework things. But when you start talking about today and the technologies today, you self-taught basically everything you're talking about right now, right? And realistically, for you to even be aware that you're going to sound embedded a Claude, whether it's Sonnet or whatever version the model was in a chip,
and Google it. You want me to search that up really quick?
Yeah, but you have to know what to look for and be, more importantly, like the desire to look. And a lot of times, education, the traditional education systems just beat you down, and it's a big filter, right? And it gets rid of, it stops people who don't want to keep asking the questions. It kills their desire to do things like just the projects that you're looking at. A lot of people your age aren't even thinking about stuff like that. So I hope you feel good about that, and I don't want to discourage you about what you're doing.
Just am doing what I'm interested in. This is something that I enjoy and enjoy learning about, so I'm going to look for stuff on it.
And so in terms of peers, I got to imagine that you don't have many folks that are able to think technically the way you do. Is that true? Do you have many friends that actually do the kinds of things you do?
I wouldn't really know. I'm not the best to ask about this because I just don't have many friends.
Yeah. Hey, look, your age, I certainly didn't, but you have a technical capability that is, we're talking about 0.5% level stuff. Most people don't even have the ability because they don't have the training or interest. You've proven that you don't even need the formal training. You can actually interest your way into training yourself.
That's how a lot of coders seem to get their start.
Yeah, you nailed it. All these Harvard dropouts doing this stuff, but why did they take it all the way to the point of Harvard? It made no sense to me. They
Well, that paper saying I did do this formally would be pretty nice.
Yeah, I don't know. I'm sure your daddy doesn't want to hear this, but it's funny. I just heard a podcast, or it might have been Galloway, saying, yeah, most of us who have had advanced degrees always say, a lot of us say, you don't need those formal degrees, but it's like we look back and say that, but the fact that we have them got us to at least to a point where we could say that, and I don't know if it's true or not, but I just think we're in a whole new world.
Yeah, it's changing. You don't need degrees as much as you did in the past. Some of the stuff they teach is potentially easier or better learned there.
Yeah.
And I still would like to learn that stuff.
Yeah. I think if anything, so that with respect to the formal education stuff, two things. networking with people, which I actually did not do much at all. Just my daughter Lily did a great deal. Hannah does less. She's doing more. It's just I failed. And that's where like formal education is really important, to network with folks, just to learn what other people's skills are, because they might be synergistic with your own, and then just be able to just learn basic social skills. But I think that's one thing I totally missed out on. I, like yourself, very much focused on like just burrowing in, just self-teaching within the normal framework of curriculum. But what's also valuable on that side of things is if you can learn techniques that give you a mindset to even be able to ask the right questions. So when I talk about the similarity search that I mentioned, similar images, I know I've done stuff like that with graph theory and even done the early graph theory. So I know how that stuff works. But even to know, I can do this concept of finding the sub-image within two images. Why is that valuable? It's helpful for annotation, but it's also helpful to ask questions of content that you don't necessarily annotate. You don't need to describe the image. Just take the image and do an image search and get another image like it. And a lot of times that's what you want to do anyway. Just these kinds of things are helpful to give you exposure to what I would characterize as orthogonal spaces that as an individual independent learner, you wouldn't necessarily know to go to those orthogonal spaces. But other than that, it sounds like you're on a great track. I just keep pushing in terms of what interests you. Follow your passion.
And that's usually what gets me into the spaces that you're talking about. I see something random and I'm like, it's interesting. And then I just start learning.
Yeah. So one of the things that kind of drives me nuts, though, is that, like you and I, some of the people who live in the tech community, we're in the spectrum of literally called people on the spectrum. But we often lose sight of certain things that are other people obvious. And when I look at some of the tech titans like a Zuckerberg or Musk, and I used to admire these guys for what they've been able to do, but then I look and see what they have a capability of doing things that they've just blindsided to. An example is I look at Zuckerberg's Facebook and Meta Facebook environment. Billions of people are just content. And he's monetizing off that, and he's got his jets and his places in Hawaii and stuff. But that content is so rich and capable of helping people live better lives in a wellness sense. And I've said this before on a different podcast. You look at all the images on Facebook, there's stories in each one of those, and people have annotated those with some of their comments. But then there's outcomes with how those people are over time, how they're living their lives. And you could correlate their images with their outcome. I don't think they're doing it in the way they can from a health and wellness perspective. That's my soapbox of today. So
don't bring that up to them. They're going to sell it to advertising.
Yes, exactly. But you reach a point where how much more money do you need?
I feel like most of them just get it off at having a number go up.
You think so?
Yeah. Like they don't seem to have really good social skills or anything, or that deep of a care for other people. So they're just rich enough not to. I don't know.
It might be that it is that number or the deltas. They're looking for changes. Visual cortex of these frogs that can't see normal imagery, but they can see differences. And have you ever tried to find like a toothpaste cap in the shower at dark or something and feel your way around, try to find it, and then turn on the lights, and the cap could potentially just be blending in with the whole environment? Do you ever really quickly spot exactly where something that's different that doesn't belong? So you have the brain to do that. I think that's a high level kind of what's going on there, just looking to be different from where they are. And they don't think of the hundreds of billions of dollars they're worth. They're just thinking, how can I be different? But it's still caught in a number. I don't know, that's just trajectory.
Yeah. Would be nice to have enough money for that to be my only worry, though.
Yeah. Yeah, I don't know. I think sure money elements is important. I just heard a real interesting story. The ex-wife of Bezos, she's just given away another huge chunk, billions of dollars this year. Like a total of like 26 or $27 billion she's given away. And there's a whole discussion. It's so much more difficult to give away money than it is to make money. If you look in terms of how many people done the giveaway versus make. I really like that concept. I like this concept of, hey, once you get to a certain level, just you meet all your needs, help people, pay it forward. And so projects you work on should be really that help people and pay it forward.
Like, it's more just a mindset thing that he's probably giving money back because she is in that situation where she has her needs met and she can go out and help people. Yeah. But Bezos has his needs met. He just doesn't want to help people. The things he does are to make himself richer.
Yeah. I think it inherently comes down to level of insecurity. They're probably these little kids.
Hard, but they're too rich for that to matter.
Oh, yeah. But they have so many opportunities to actually address some big issues. The big issue in the room is healthcare. It's a major issue. Right? We're an aging population. You're still young. You don't think about this, but the population's really getting older, and especially in the States, and they're very expensive. And medical is just going to break the bank on the whole country, and it's going to affect everyone, including people in your generation. So addressing healthcare needs, I think, are critical. I wish all these tech folks would think in terms of not how we can make money on people, but how can we get people to be thinking a little bit more towards wellness and avoid the healthcare cliff.
This brings us to like larger societal changes that we'd have to make.
Yeah.
For that, you need money. So we should take the rich people's money.
Yeah, I don't know. They don't need it. That's maybe one solution, or maybe encourage the rich people to apply their money to help and fund and capitalize on it. Yeah, but I agree to a certain extent. I think, again, a lot of these things that we work on from a technology perspective, they can be applied in these areas. I'm just saying it's all about the application. And yeah, it's not about selling more ads and making more money. Let's apply it towards bringing level up for everyone. Because ultimately, if you think in terms of yourself, you're going to benefit. It's kind of like herd immunity. It's got everyone to benefit. You're going to benefit.
Like in the 80s, companies would give their workers a lot of profit because they knew if the workers are happy working, they're going to work better.
Yeah.
Now it's at cost. Give them less money. It doesn't matter if they work better. Just fire them and hire another one.
Okay, so this is where it's really interesting now that you're like dialed into AI. You're in a generation that most people your age are not thinking about AI to the level you are.
I'm in a generation where this funny thing in my computer is taking all of the jobs I could do, and I'm not going to be able to live.
Yeah, but don't you think that there's opportunity there?
Only a little.
No,
I don't think there's enough opportunity with AI to make up for all of the things that people are trying to replace with it.
First of all, anyone who works behind a keyboard, knowledge workers, likely in jeopardy if their jobs, if they do not embrace AI. That's a given. But then, even then, how do you get to a point where you aren't going to even lose your position when you embrace AI to AI? I don't know if we're going to be there yet, but when you think about future employment opportunities, are you thinking in terms of being employed, or are you thinking about employing?
I'm thinking in terms of being able to live. I don't have the money to get an apartment for long enough to be employed, and I don't have the money or the space to be employing.
So I jumped to a harder question. So that's like you jump in C++. So let's start back to something more simple. Right? In the early days of the iPhone, the first app developers put out very simple apps. They were printing money on it. There's opportunity, I think, in the AI environment now, various agents and frameworks. I know OpenAI is working on a strategy for a developer network that you could exploit, but do you think there's potentially like one of those early iPhone-like apps in the AI world that you could get out there, give it away, and then maybe somehow monetize based on support or some piece that had it. So what are you thinking?
That's definitely something that you can do. My only hope at this point, I have to make something and hope it's just that hits.
Right. Okay. That's a great statement, because if you do that in vacuum, you will fall into the trap that most entrepreneurs fall into, and that's they've got a ton of failures and then they eventually get a success, but they keep failing, keep failing. If you just create something hoping it will hit, your probability of hitting is very low. If, however, you're creating things that you know will hit, how I say that, if it means and is useful for you and people like you, if you're eating or building your own dog food that you're eating, there's a good chance it's going to hit.
Well, that's usually why I make something. Like, I have a folder in my computer that's just random little things I made that are helpful to me. Someone else might find use in them, so that could be a little micro hit in the space of people who would use that.
Yeah, and so the question is, how do you gauge that before putting too much resource in the scene and trying to sell and monetize it? Give me an example. What are some tools that you find that you couldn't live without that you've developed?
Honestly, just for running AI on this with limited RAM, a tool that I can't really live without anymore is a script to clear my RAM.
Yeah, okay, that's definitely key. Yeah. What else?
Well, I've got little local models that I can bounce ideas off of to write text better.
Wait, really? You mean you like language models?
Yeah, I have plenty of models that I run locally. I've played with them enough to know what kind of things they're good for and not. And if I want to, say, write something meaningful, I would probably just come up with my bad ideas and bounce it back and forth between an AI until I can land on something that I like and just work with that. It's a lot easier to start when you have something to start from.
It's really cool. You start with like llama models. What are you using?
Qwen 3.
Qwen 3. And so, where'd you get that?
Hugging Face. I just gone to the fine-tune section of the Qwen 3 model.
Interesting. So you download that puppy and it does no call home. You can run it completely without a network. Mm-hmm. That's huge.
It's completely run on here. I do the same thing for image generation.
And so how much disk space do you have?
About 3 terabytes.
Yeah, that's... And that's what
more? This is already a lot. One full backup of my old tower computer was 300 gigabytes.
I just upgraded my box. I think I'm now 16 terabytes, and I know I'm going to need double that soon. One thing you can always be sure is... One of the things that you're going to be sure is you will always need more disk space. But I like the fact you're constrained because on your device, because it gets you to think through the problems and get more focused on them, just like the early Mars moon mission guys had such small footprints to work with. They had to really think through their algorithms. So you get sloppy with too much memory and too much disk. But
why I don't like AI coding, it's trained on mostly the people who know they have all of this to spare.
Yes,
but
yes.
I like to build my own things from the ground with the idea of just make this as fast and minimal as possible.
Yeah.
But still do the things I want.
No, that's quite cool. That's quite cool. Okay, is there something you can show me? I'm curious. We're doing time. We're crushing. Oh my gosh, it's 5:30. But go ahead. What can you show me?
Most of my work into the thing I was talking about earlier, the voice synthesis, has just really been making my own wave function.
Okay. So is something I'm going to be able to hear, or do I have to see it?
You can hear it.
Okay.
I'm typing a password in. I put this to sleep earlier.
That's right. You're looking for the camera to make sure no one would capture your fingers. What was the kind of plot it was?
It's a plot of the fast Fourier transform of the that I have generated here.
Cool. Let me ask, first of all, because at 17, how do you even know about an FFT?
I don't remember where I first heard it, but it gets talked about quite a bit.
Yeah.
I know there's a great YouTube channel that has posted stuff on just digital voice synthesis and stuff that I watch. Do you do that here.
No, I don't actually. YouTube videos bore the crap out of me. They take too long to get to the point. But so that I am just amazed. Literally, I didn't even work with FFTs until second or third year of engineering school in college. Okay, and holy crap, that's impressive, big guy. Okay, and so you're using that for you have the sound, basically the sound frequencies that are coming in. You FFT'd that time series? What did you do?
Not really.
Okay.
You can see here, it's this one resource I've found with just data on how a human voice is produced, like how your throat and all filters it.
So that's basically a frequency over time, right?
Yeah, most of what I'm doing here is just recreating my own generator for that.
Okay. And so you're curve fitting that, and you use an FFT there? What'd you do?
Actually, the only time I'm using the FFT is for generating that plot. Don't use it at all.
Oh, okay. I'm sorry. All right. So you've got the sound frequency over time. So someone voice articulating something. Got that curve. You're fitting the curve?
Kind of.
Okay. What are you doing?
If I uncompress all of the stuff here so that you can see all of it, what I have here is this is using PyTorch, which is like Google's thing for GPU compute. I have it making a list of values that I can kind of just run wave functions over so that I can get like a sine wave or something. So I have that implemented here in my own way, and I have here I have functions to filter it, so I can change the sound of it and different waves to make. And I just take a bunch of those and, like some of sines, I approximate a human voice by combining them together and filtering them in different ways. The stuff here, do you want to hear different samples of the waves?
Let's hear it. I don't need to see anything visually anymore. I can just hear it now.
Yeah. So these are the different waves that it can produce.
They don't sound like human vowels or consonants, so how do you get them there?
Sorry, that one's a bit loud. I decided that it would be fun to use a tangent function to make a wave.
Yeah, it's because you always worry about division by zeros, but go ahead.
So what I do is I have this function here, which takes noise. It injects different waves into it at different frequencies, which are the resonant frequencies of your vocal tract at rest.
All right.
And then I have this one, which really all it's doing is inserting more frequencies in.
Okay.
But just adding all of them together does result in sounds like this, which are vowels A, I, and U.
Okay, let's hear them.
Bit hard to move it sideways.
Okay.
It's like just the first version.
No, I get it. So
that's all I've done so far.
that's quite cool. So you're piecing together. You're basically summing a series of frequency over time waves to try to arrive at what the actual pattern is for a particular vowel or consonant. And how are you doing that? Are you doing it systematically, or you're trying to build an AI to predict?
Right now, I'm doing it myself and just hearing my own feedback of it. But eventually, I do want to have the AI make all of the different frequencies that go into the sound.
So I'm curious, have you thought about this a little bit? I only speak English and a ton of computer languages. Do you speak other languages?
I am currently learning Japanese.
Ooh, okay.
I took a year of Spanish and forgot most of it.
But so the languages that have alphabet with the letters that look similar to our normal A through Z, right? The shapes of those, from an image perspective, are you trying to go imagine a convolutional representation, right?
No, this is just text to speech.
Just text to speech. Okay. Yeah. All right. Okay. That's cool. Imagine that you could decompose the actual true sound of A, E, I, O, U into a set of waveforms that have more pure sounds to each one of those waveforms. And that's ultimately when I say orthogonal, looking for different waveforms that are pure and unique, but if you sum them all together, they form that particular vowel or consonant.
I can do that here, actually.
Okay.
Might take a minute. 'Cause
Yeah.
I have to tangent.
You're coding on the fly. Impressive. That's hilarious. You are one focused dude. That is an all-time first. Here, I got a Python code on the fly. See, this is why I would definitely encourage you to start using some side tools more. Because the way I would do this right now is I would literally pull up Droid or Claude in dangerous mode or Codex with approvals 100%, and I would just say, I have these waveforms. I want you to construct these and write a generic algorithm to come up with up to 10 different pure frequencies that can, when summed together, can form those final sounding sound segment.
That would be
Go.
pretty convenient. All I've really done here, though, is just comment out the thing generating like all of the noise and fancy
Okay.
stuff and replace
Okay.
it with just pure sign.
No, I know. But I'm saying that you are getting the code to do that. I'm just saying what I just described is how I would attack this problem now, and then it would go and do it, and it would be kind of shit on the first pass, be about 85, 90%, and I'd cycle. And in about 10 minutes, I'd probably have a fairly generic utility to do what you are coding right now. That's why I really want to encourage you to get there, because you have a capability to code. I know you like coding, but the next level is knowing what to code, because you have a problem you want to solve. And if you put all your mental energy on that latter thing, you're going to be even more productive. So it's something to think about.
I don't really have an issue with that one, actually.
Really?
I can break a larger idea up into smaller things that I need to make that final product.
Sure. But it's about the time.
Yeah.
And I know you just coded out, you commented out, but you only have a limited amount of time. So let's say within an hour, all you had is an hour to work on something. You could be far more productive if you took at the high level, say what you want to do, and it code for you, than for you to spend that hour to actually code the sub pieces.
I could be, but I do like to know exactly what it's doing.
Yeah, you're right. I get it. So it's, I guess, what you enjoy most is what it comes down to. Do you enjoy the actual act of the building, the sub-components, or do you enjoy more having the full application that's running? Where do you get the most buzz?
It's like a mix of both, but having the full thing is just disappointing to me. I see it, and it's cool that it's done, but I still want to work on it. I still want to make it better.
Yeah, I get it.
And
No,
I want
get
to
it.
stop programming.
No, but the point is then you move to another project that's even more interesting. So the question is where you feel most charged by, and if you feel charged by building the components, I don't want to discourage you, but I'm just saying that there's a whole new world where if you turn that attention to building new app ideas, instead of building 40 components to build one app, you could build 40 apps that are really cool. So something to think.
My other problem there, though, is also just that for some reason I am lazy when it comes to my internet usage downloading AI models. So
Yeah.
my current models that I have locally aren't good enough to
Yeah.
do the code,
Yeah,
and I
yeah,
just
yeah.
don't want to go get one.
No, first of all, at the same time, I take for granted that I'm spending like $1,000 a month on different AI models that enable my coding. I take for granted that because not everyone can just do that. I spend that kind of money on those kind of code tools. First of all, I run a software company, so it's a part of the business. But I know that if I were to employ software engineers, it would cost me hundredfold to do the kind of apps I'm doing. So I think of it as a cost reduction, but you're not thinking that way just yet. But when you do get that first app out there that hits pay dirt and a ton of money's coming your way, it doesn't have to be a ton. If you drop $25 a month or $200 a month or whatever it is to pay for a good model, I would encourage you to think that way when you get to that point. For the moment, you are building the apps like the moon mission, and you're getting really good at doing that sort of thing, which means you're going to be even better building the kind of apps I'm talking about.
I might think that way in the future, but I will probably eventually be replacing even that with something that I've made, just because I don't want to have to go back in and make sure the AI code is what I want. I would like to have the trust that I built this system to do what I want it to do.
Yeah,
it's gonna do that.
I totally get that, and you're always gonna be frustrated about something. And driving here at a stoplight, my AI Steve was not replying back to me in my email, and I put up email poller that uses S3 and Amazon buckets and all this stuff. And it didn't send me my damn message. And it did do that this morning. And it's because I had AI code something else and it broke something. That pisses me off.
That's like the main thing keeping me from it, other than just not wanting to download a new coding model.
Exactly. Yeah, that's pretty cool. So that sound stuff's pretty cool. And you mentioned going with that. Ultimately, do you think this is going to get you to thinking through a different strategy to tokenize for what you're doing here? Because in a sense, you're doing little tokens. These are sound tokens.
Honestly, my first thought for what I would want to do with this is just not even have it be AI, just use the optimizing function to just do it without any of the randomness of AI. I don't like random systems. I don't like noise.
Yeah.
I want it to be the same every time I run it.
Yeah. No, I totally get that. So you're definitely deterministic again. You expect
I can't test a noisy environment.
Yeah, no, I know. Unfortunately, the world is noisy. Yeah.
We only get one chance there. I can't really test anything here.
No, that's cool. Look, I think you're doing some cool stuff, and keep asking the question. The way I look at it, because that's how you're teaching yourself. Tell me what was something you learned new today from a technology perspective? I'm just curious, because FFT already blew me away that you were doing that now, but what's something new that you did today?
I learned that the larger AI coding models are good enough for people who have degrees in the field to work with them and think they're good, so I might try it.
Oh, yeah. I don't know if I've told other people this. In my career, and you probably don't do word counts or line counts on all your code, but I do every once in a while. In my 35, almost 40 years professional career, where pretty much I've formal training in software engineering. In that time, I've built a whole slew of applications, probably 3.5 million lines of code. Okay, 3.5 million lines of code. So in a million lines of code every 10 years. I'm approaching 10 million lines of code right now in the last 10 months. 1 million lines of code a month. And this is highly efficient code. I built more applications in the last few months. Just this image search stuff that I did in 2 hours. Dude, that would have been weeks of my work just burrowed into my man cave of just code for hours on end. And I just literally, before I went to bed, I wrote a paragraph of text, prompted Droid, it's actually my favorite, prompted it, and it uses a bunch of agents, and it just went. I woke up in the morning, and like I said, it was actually closer to 90% of what I wanted. That is just, to me, that's exciting as crap. So, yeah, these models are phenomenal. All these programmers, that's why every one of these major leaders in these technology companies are basically saying, dude, the NVIDIA guy said, I want all my coders to use Cursor. Every one of these guys are saying, I'll just lane people off coders, because I can do one person can do 10 to 50 coders work. And it's easier because you can speak it. Oh, by the way, I literally speak it. You were flying and you type what, 100 words a minute? You're just crushing there. Do you know what your type speed is?
I have not tested.
Yeah, it's fast. Holy shit. And your body's very firm. I'm like, that's right. I use Whisper. Have you ever heard of Whisper?
That's the Google
WISPR.
one, right?
No,
I don't know.
I don't know if Google funded
I've
it.
heard of it. I forgot who made it.
Yeah, so WISPR, it's voice to text. Really good. So if you normally like iPhone or Android, you type the microphone and you voice to text, it's not so good. Whisper.
I was going to search it up.
Yeah, you can remember it. But I have it my desk right now. WISPR. It's not spelled the right way. WISPR.
A YouTuber I watch has used that before.
Yeah. And so literally, how your brain works. It's great how you recalled that right away. I have a treadmill that I walk on in my stand-up desk, and I talk out all the stuff I've just described. And so I get pissed when I have to literally type now. It's crazy. And Whisper will do the calculation of words per minute. And last time I looked at it, it was like 140 words per minute is what Whisper will generate for me. There's no way I could type that fast. And it's really good. It put punctuation. It even, because I often shouted it, and my wife hears me do this all the time, like calling it a dumbass, it factors that out because it knows the LLM doesn't need that shit. So it's really good. And so I pretty much go verbal language to code.
It still has that in between of text just on the screen and all that, though. And that's the part that stops me from using it.
You don't want to see that?
No, I don't like having another layer of abstraction in between me and what I want to make.
You're doing that anyway, but you're generating is a difference.
Yeah, but if I can type it out, I don't have to be worrying that the speech to text model is not accurately representing what I've said.
Yeah. But I mean, do you look at the screen when you type, or you look at the keyboard?
I look at the screen.
Yeah, so you're a good typer. I still look at the keyboard, so I have to go up and down real quick. And the best programmers are just watching it flow.
I will check on my keyboard to make sure my hands haven't moved, because I have had plenty of times where I go to type something and I know where all the keys are, but I set my hand down wrong and I type something completely off. Yeah, you'll fix it. But no, anyway, it's Whisper, I think, is free initially, and then you have to pay for it. But it's really cool. I don't know if you find yourself more comfortable being able to type versus speak, but I would say the accuracy for me is, especially if you have a good microphone nearby, that's going to be pretty good for your laptop. And you could speak very fast. I don't know, but it's pretty good for me. And the thing is, I think it learns as well, so it knows the words I would use. I don't know. It's something that, for me, it's to the point now that I do not want to type. I only want to speak. I want to go from, at one point, just think it, but speak it, to visualize the result of it. And everything in between is just, I see as human abstraction that's just getting in my way. I get annoyed with speaking and my voice.
Really?
Oh. Yeah, I prefer to do things over text.
Yeah, there you go. You want to be quiet. I get it. Yeah, okay. But no, there's some cool tools you're aware of that I was going to throw out at you, but you knew about them. I would definitely encourage, as you get time to think about these. Not within Cursor, I'm not a fan. Go directly with a Droid or a Codex, or Gemini has a CLI. Codex is OpenAI's. Claude is Anthropic's Claude. Droid is, I think it's Factory.ai. Gemini CLI is Google. And I like they all compete with each other.
Google has like a kind of open source version of Gemini. But
do they?
They're a Gemma model.
Oh.
I can download that and run it.
Oh, that's cool.
I have. They're not great.
Yeah, of course, they're not going to give away the good stuff. But yeah, you literally open up a terminal session, and it's just a prompt, and you type what you want, and it interacts with the file system. It uses NPM direct, creates files, edits files, can run things, launch. Basically, anything you can do on your computer, you either have to authorize it to do it if it's they're concerned about it, or somebody which I truly enjoy, it just does it. So I'm to the point with even file system tasks. If let's say you write a program that delivers files in this weird array of folders, and you're like, oh shit, I need to clean this up. You just basically can instruct it and say, I want a file folder structure that digs in these files and identifies the year and month. And now I want you to folder it up by year with subfolder month. Go. And it, of course, will generate the Python to do it, run it interactively, and all the files get moved. It's like it can do some even day-to-day housekeeping tasks. Even
You mean that, but usually I don't have it output data in a structure I'm not happy with.
well, that's pretty impressive because your state of mind changes depending on how you build on top of your applications. And so you're still working with, what's the most advanced application you've built?
Let me see what I haven't deleted yet. I get upset later and completely remake things.
There you go. No, that's good. That's a good habit.
I have this 2D game engine here that I'm currently working on. It's mostly just a bunch of folders where data would go and loaders to load it.
Okay. What's the 2D game do?
It's just a game.
No, I know, but what, I mean, is it visual with things moving around, or?
Yeah, you played a computer game. Sorry.
Yeah, of course. I don't enjoy them as much just because it's a waste of time for me. I don't get a real result from it. But what's the premise behind the game?
It's not a game specifically. It's the engine behind it so that I can make many games easily. This is normally how I do things. I don't make this specific task. I make a tool that I can copy around when I need it to do this thing. That's also usually where half of my sub-projects spawn from. There's this other interesting thing that I will make a tool for the larger project in while making it. So I just have fun doing that and re-implement it in the larger thing.
So I'll just throw this at you right now because I did my PhD at Berkeley in computer simulated neural networks focusing on predicting features of protein structure. That was the thesis title. But in order for me to get the PhD at Berkeley, I needed to be able to do something novel. You're doing that all the time. Something that was not written in textbook. I had to use a new approach or whatever, novel. In my lab, I had to fashion the tools that I needed to use in order to do that novelty. So I actually had to build neural network simulators. I had to build the engines. I had to build the system to train neural networks. All the stuff that they do today that you find in Python, I literally had to build that stuff. I was doing so many neural network simulations that I wound up saying, I need to build a tool to build that allows me to bring things together. So I had to write my own scripting language. I wrote a computer language in my neural network simulator that could do loops and conditionals and all that stuff. That was necessary for me to basically, for my PhD advisors, say, okay, you published a few times, great, but you had to build that tool and use the tools to do some things novel. Sign off, put a diploma on my wall. You are doing that daily, basically, right?
Just works better that way.
But that's my point. And so I just want to make, back to our point about long-term change, mindset, education, that sort of thing. You don't need diplomas for that kind of thing. And I know you piss off. Yeah, I'm talking about like high school and whatever. I'm talking about like future education stuff. You are kicking ass and taking names, dude. Because you're doing stuff that basically there are people who spent 5, 6, 7 years doing their PhD and still haven't figured out.
That's the plan, honestly, to just take down names in college.
Yeah.
I am actively getting rid of like normal college coursework right now.
Yeah, that's good.
In the next semester, I am doing a year of college work.
Yeah, that's great. And then I encourage wherever you do that to get the actual network and people in the college you go to. But then ideas. What ideas stick? What dog food should you be working on that you know you enjoy eating, but other people enjoy as well? Use that as your framework. Facebook came out of the Harvard network, all right? Google came out of Stanford's network. Actually, one of my investors was investor behind the Sun Microsystems, which is Stanford University Network. These universities, it doesn't have to be like top tier. It could be any university. It could be a community college. It doesn't matter. These are frameworks for which you can field test a lot of your ideas with peers.
The main thing I want to work towards right now is just a large language model, but smaller.
Yeah.
We already know that people like LLMs. We know that companies like downsizing and saving money.
Yeah.
If I could make something similar to an LLM that is just smaller, faster, easier to run, I could probably sell that to AI.
Yeah. Or just deliver it out there yourself and just sell it to other people and say that, look, when your concerns people should be, every time you use, whether it's ChatGPT or even some of these coding environments I've talked about, have to go to a SaaS model. In other words, software as a service. For now, it's free, or some of us have to pay for the more advanced forms, but you still have to go out to use it. People have an environment that runs locally on your machine. You don't have to worry about the privacy. You don't have to worry about people raising prices on you. It runs on your device. Sounds to me like you've got something then, if you put it in terms of applications that would stick, get it out there and kind of Linux. You give it away and eventually people will fund you. So it's something to think about. I don't know.
It's my whole idea behind the things I make. I hate it when something depends on something that isn't like part of it. I do not like it when I have to depend on another service.
Yeah, and so unfortunately, you're working on a PC right now, right? PCs, worldwide, fine. Macs are more standardized, but the environments that people are working, they're all different. So you need something completely self-contained, completely. Do you ever have to install things in order to get your stuff to work? Or do you have like installers that basically everything it needs, boom, it's good to go?
Well, past just installing the apps that I use, I don't really have to add anything onto it.
Yeah.
Unless I'm doing something new.
Yeah, well, it's something to think about. One of the things that I know that the Claude, Codex, Gemini, Droid, all these guys, they're really good at. They all look the same, by the way. They have one command on their main web page. You paste it in. It's like an NPM type thing. It assumes NPM's installed, so that's one thing. But it just does all it needs to install. And then it's good to go. It even updates itself and stuff. But it's still, again, that still calls home. And it sounds to me like you want to, and you should keep things locally. So, no, hey, cool. You're on a great track. I go on forever. It's already 6 o'clock. Holy crap. Your dad's probably like going, what? He's going, okay, you're done. But I don't know if he appreciates we coders. This is nothing. We probably spend 10 hours just coding.
He thought we'd get more into the morals of AI and what makes a human conscious.
Screw that.
I like that.
Do you like that? You want to get in that? I'm sorry. I didn't know.
We can.
That. Yeah. Do you think that's actually, it's critical. That's a really, what's your thought on that? What's your position on that?
Which part of it?
The whole morality issue, and should we be using, or what's going to happen? Are we going to Skynet it? Is that the term? The Terminator stuff?
I think we should. I think we deserve it for making machines and then choosing to give them consciousness to do things we don't want to do.
Okay. What would you do if suddenly you couldn't do what you're doing right now, code-wise?
Explain.
If you freed yourself up of all these tasks that involves the silicon, what would you do? Do you have hobbies outside the computers and stuff?
My work is on here. My school is here, so probably nothing.
So what do you think would happen to our society if people were completely liberated, if you will, of these kinds of work, these tasks?
Eventually, we'd find our way back to it.
You think so?
Yeah.
Yeah. I guess it depends on how many hobbies you have and all. Some people don't like their jobs, and they do their jobs as a means to the end, and then they go and do what they really like to do. But if people are totally freed up of time, I don't know if people are disciplined enough to how to use it. Something that would be my bigger concern of that. But I know there's already pushback against AI, and it's growing. There's a big faction of us in this world who like want to push the envelope. But there's a bunch of people who say, don't be building those data centers in my backyard, right? And, wait, I'm losing my job to AI. And then they start getting rebellious. And then suddenly there'll be this pushback where, yeah, maybe let's cut the cord. Let's not have any AI. Our society is, I don't think, disciplined enough to really embrace fully the kinds of things you and I think about with AI.
They don't really have the power to stop the AI because the companies basically own the government with their money.
You could argue that position. I think that's a fair statement. But the one thing that is clear, AI's tired. And it's certainly ones that the current LLMs, you have to refresh your sessions. You have to exit out because the token links can only go so far. You can argue that they could get even larger, but they eventually start to get fuzzy and not as productive. I've seen it. I'll work with my IDE, Claude or Codex or whatever, and I'll sometimes be using a session for 5-6 hours. And it's pretty clear. When I first started, I still have to bring it up to speed, define what I need to do. And it's very productive, just like a human being. But over time, it starts to decay. And I think there's going to be this situation where the people who say, let's use AI and eliminate all these knowledge workers, they're not going to appreciate the fact that AI still has this very similar behavior that humans have. That it's going to need breaks. It's going to need to be refreshed. It's going to, that kind of thing.
A lot faster and cheaper than a human, though.
It is.
The human they have a lot of the day off to go home, eat food, sleep.
Yeah.
They have breaks on holidays to be with loved one. If an AI get too long in the context, you ask another one to summarize the history and feed that into the same AI.
And I'll have literally these 3 or 4 AI environments running at the same time. I do the same all the time. But
you can copy my knowledge worker.
You can. But biologically, we all evolved the need to sleep, which is a way to cleanse your brain. I suspect we're going to have to start working on strategies like that with AI, where you have to give it breaks. Just call me. That's at least using the current models today and the approaches people use today.
I don't like the approach people use today. It's very obviously non-functional and limited, and they're just throwing more things at it to expand it to its limits, but its limits are short now.
Yeah, that's true. That's fair. But so in terms of should we, the question, the moral, should we really push the limits with AI? I believe we've achieved AGI, but that's my perspective. Should we keep going to that level? You just still believe we should keep pushing?
If I don't, someone else will. And I want to be first.
Yeah.
So I'm going to keep pushing.
Yeah, that's fair. No, that's fair. Okay. Yeah, like I said, I think there'll be enough pushback. One of the things that it was pretty clear when you observe how our human society, especially in the States, behaved with COVID. If people did what they should have done, and that's just isolate for a few weeks, maybe 6 weeks, we wouldn't have had a multi-year pandemic. But they're rebellious people, or don't take me away from my bars, let me spit in each other's faces. It's just like they don't get this concept of just keep it to yourselves for a period of time and it will die out. People couldn't see the bigger picture. Our society is not that smart. Did you know that half our population in the United States, half, can't read beyond, I think it's like the 5th grade level?
The lawyer in my head is advising me that I should not give you my views and opinions on human.
No, you got your father in the back saying amen or something. I don't know what's going on back there. But no, look.
He's telling me to stop because he's heard it.
Oh, okay. No, but here's the bottom line. You do enjoy what you're doing because I see there's a passion. No one can do what you're doing without a passion. It's not like someone daily telling you, get up in the morning, get out of bed, code.
Actually, most of it is me telling myself, stop bed rotting. You
Yeah.
have to do schoolwork today.
Yeah.
No, you can't just stare at a YouTube video all day.
Well, you're producing some cool stuff, so I'd say keep focusing on that. There's some cool stuff there. But no, hey, look, we go a long time. I actually have to eat as well. But, dude, you are kicking butt and taking names. Keep it going.
I do have, if you want to hear it, the sound of that I vowel.
Okay, let's
but
hear it.
Your sine waves. That's it without the noise.
Sound like an E to me. That was an I?
Not using English pronunciation.
Oh, okay.
I-U-L.
Okay. Yeah, no, look, it's come along. That's really cool. Keep at it. Keep punching.